Okay, hello, welcome to GPC. Today we are going to talk about the game pipeline, which is exciting. I've been wanting to run this session for a while. So, just for some context of what I do, because this is a me session. I do gameplay programming and I do quality assurance stuff on my team and also just in general. Um, and I kind of learned this stuff through my experience in Capstone and also just looking around at different GDC talks. Speaking of talk, who's the session for? Well, if you're interested in indie dev, improving your GDW team's workflow, gaining insight on things, how things are done in the industry, tools programming, team dynamics, project management, putting your all into GDW, any of those things, this session is for you. So, let's talk about the development cycle. Now, when I say this, I mean like, you're just getting into GDW. Most of you guys are in second, third year now, or graduated. So, you'll understand how it kind of went where, you just kind of slap things together. You set up your times and you get things planned, and then you start laying down the bricks so that you can build something up for the reviews. And you build and build and build your monolithic kind of tower structure until you get to the end of the year. By that time, you have what you have. But there's kind of a lot of problems with this kind of way of developing. First of all, we're still learning the fundamentals as students, but in general, in the games industry and in tech in general, you're always going to be learning. So by building our applications, kind of stacking them in monolithic bricks, what happens if we need to change something on the lower part of the tower? Is the rest of the tower going to collapse? It's not a very modular approach if we kind of just rush things and just get them done. So monolithic development is bad. It's inflexible, it's disorganized, it creates opportunities for crunch and low quality work. And I'm sure that if you're a programmer especially, you are very used to the idea of going, oh God, it's review day tomorrow. Let me get all the features into the game and actually make something. But I mean, you've got this far. Why is this important? Why bother trying to improve this process at all? Well, we want to use our time efficiently. We want to not burn out. We don't want to lose the passion that we have for making games, and we don't want to cause culture problems, and we don't want to crunch. Nobody wants to crunch. And most of all, we want to be able to react to problems as they come up rather than discovering later down the line that, oh, maybe this feature has a bug or blah, blah, blah. So, where do we even start with rethinking all of this? Because I mean, it's not like we've all been developing games before, really. And, you know, if GDW is your only experience, then you don't really have a lot of insight. Well, that's where this session comes in. So let's start with what does it take to make a game project? It takes fleshed out design of a game. It takes time and commitment, and it takes game developers. So the first thing there, the first point, the fleshed out design of the game is the most important part. You need to know what your game is before you start making it. Don't make the mistake of designing your game as you go along. Try and solidify your ideas in the beginning. And time and commitment here is probably the most important element. One person was mentioning that they have a GDW team member that is slacking. Um, you need to get on the same page with everybody on your team about time and commitment and be honest with each other about how much effort you're willing to put in. And project management here is the efficiency in which, or the ability to manage the efficiency in which we use that time. Because time is the most important resource when it comes to making games, besides your people, which are your game developers. You need your programmers, you need your artists, and you need your sound designers. Without any of these, you will not have a fun or functioning game, depending on the role. So, just to reiterate, all these roles are important, but they all have their specific parts that they handle, as we're all aware. So moving on, if you're going to take away anything from this session, don't worry, we're nowhere near from done. It should be the power of the build, because we kind of get into this groove where we kind of just build towards, oh man, we have a review in 2 or 3 weeks or whatever the timeline is, and you slap things together, you try and get things done, you don't really get to test it to see if it's something that you like, and it's just a very messy, monolithic approach. So how do we make it modular? We make builds. Builds are runnable versions of your game outside of the engine, executables. They represent small chunks of progress, and you can do all sorts of things with them. You can prototype, you can playtest, you can actually have something to show if you need to show other people, and it allows you to see your progress. It keeps your team motivated. And if you schedule your team in a way that, you make builds once per week, if that's something that's possible for you, or maybe every couple of days if you're really, really trying to push it, that is something that's going to enable you to do that kind of testing as much as possible, which ultimately is going to provide the iteration that is so great in game development. So let's talk about the game pipeline, the namesake of the session. This is the kind of process in which you actually develop the game in a nutshell. This is a feature by feature sort of breakdown. So we have the design of the game, we have our ideas, all the documents and things are laid out, and everybody understands what the idea of the game is. That's the basic assumptions that we have here first. So we take that design feature and we send it off to the programmers to prototype. So they're going to try and make a prototype version of the feature, and then we're going to see basically, do we like this feature or not, and should we continue with it? The next step is to create the content for that feature. So that's where your artists and sound designers are going to be creating their assets to actually put into the game, the more finalized content, if you will. Then you're going to send that back off to the programmers again, and they're going to implement that finalized content. Now, once everything's all good, they're going to merge that into the build. And you keep repeating this process until your game is finished. So just to break it down for each individual role, the designer's job is to explicitly design the feature and to evaluate if the prototype feature fits into the game. So they're basically the people that should have the final say of whether or not this thing actually fits. And again, it's okay if you're wearing multiple hats here. That just means you have to have a discussion. Communication is very important. So the gameplay programmer's job here is to create the prototyped feature with modularity and change in mind. Maybe the designed feature isn't exactly what we want, but we don't know what it might be. So we have to be prepared to make our features modular. In that case, we allow our things to grow and change organically through testing. And once that gets the approval of a designer, and you get some maybe prototyped or finalized assets, the programmer is then going to be the one responsible for implementing that content and merging it into the build. So the artists and sound designers here should be creating very, very low fidelity assets for the programmers to work with if need be. So for example, um, maybe the programmers don't really need a gun to make the gun system, but maybe they need like a basic idea of a skeletal mesh to make an interactive enemy. Making a basic version of that will very much reduce the waiting time that the programmers have to go through when it comes to implementing those features. In addition, the artists can also prototype their different ideas and see if they like them and they fit with the vision overall. And then finally, as mentioned before, they're going to actually create that proper content and send it off to the programmers. And yeah, once again, this cycle is going to repeat until development is finished. So the main thing about all of these different phases is that you can test at every single different phase. You're organized now. You can take each chunk of this pipeline and see, does this actually work? Is my code good? Are my assets good? Can I compare with somebody else to ask them their opinion if their particular area of expertise is the same? And this is also the part, or not this, the whole thing. You can do testing for bugs and errors in general at each stage of this pipeline. It can be an error in the design documents formatting or something that is like completely different from what you meant to type because I don't know, maybe you were tired one day or something. Or it could be like a super game breaking bug that causes your game to crash. Either way, testing throughout each different phase of this pipeline is a very effective way to make sure that you're actually making the game that you want to in an effective and optimized way. So let's talk about project management here. Because let's be honest, the project management course that some of us have taken, at least if you're not in the first year stream, it sucked. It didn't really teach us things that were very relevant, and that's part of the reason why so many teams have trouble outputting products that they're happy with. So let's talk about Agile. Agile is the principle that it's basically the idea that software projects are these things that need to evolve organically and be able to adapt. They're not rigid. They need to be able to pivot. And the other idea of Agile is to kind of break things down into bite-sized pieces, kind of like what we did with the game pipeline. So, some of those pieces include tasks. Tasks are things that need to be done. They take an approximate time. So, for example, I might have a weapon system I need to implement, and it might take me 3 days. That's a task. A scrum is a 15-minute daily update sort of thing where you talk to your teammates about everything that's going on um, with your work, and you can communicate with fellow team members. Ideally, you have it once per day. Now, you might say once per day, oh my God, that's so many meetings. But we'll get into the breakdown of the actual time on the next slide, because those monolithic meetings you're having right now are unproductive and bad. So sprints, you might be used to this concept from GDW reviews, but the thing with GDW reviews is it's more about presenting to a client rather than checking in with your timeline to see, did we complete all the tasks that we're doing? Did we get all of our goals done? You're more so, again, in GDW, you're just thinking about getting things done rather than evaluating what's going on. And that really is the core thing about the game pipeline and project management here is to be able to look at your work and evaluate what needs to change. And the ways that you're going to do that is through tracking tasks and tracking your time. So some example tools of being able or of doing that are Jira and Clockify, and we'll get into why it's important to track your time in a couple of different slides later down the line. But basically, if I were to give an example of how a sprint would work, you have, let's say, a 1 week sprint where every Monday everybody meets and your tasks are assigned. You give each other, or your project manager gives everybody 1 week's worth of tasks. Every scrum in the following days, working days, by the way, not on the weekends. Please don't work on the weekends. Um, each of the following days, you update everybody on what's going on so that the project manager can adjust things as need be and so that everybody's on the same page with how the game is being developed. This is important. It's very important to be communicative. But just to summarize, long form meetings that you had before are not frequent enough. They cause communication breakdown. They're not productive enough. You feel like you're all over the place and you don't know what's going on. They take up way too much time and they make you feel exhausted. Just getting it done creates bad work, it allows for crunch, and is inflexible. By taking a more thoughtful approach with scrums and batched work, we can have small, bite-sized, quick communication meetings, which means less problems and surprises, and you can ask for help more easily. To put it into perspective, if you have 2 3-hour meetings per week that are spaced out, that's 6 hours of meetings per week that you could be spending on actually working versus five 15-minute meetings over 5 days. That's 1 hour of meetings versus six. You've already optimized your team's workflow by a huge factor. You can still have one longer-ish meeting if you want, but the idea here is to keep inside the time limit. And the reasoning for that is because if you force your team to be constrained by time and realize that it's not an infinite resource, you're going to be more efficient. And speaking of being more efficient, small batches of work, aka builds, will allow you to find more errors and be more flexible and see what actually works versus making things just to get a good grade at review or get something done. So I've kind of been sneaky up until this point because I've kind of just summarized the main ideas of DevOps, but in the context of GDW. So let's go over all of them. We want to make small batches of work at a time. We want to ensure that work is flowing in one direction down the pipeline. This means that, if there's a problem with the design, we catch it at the design portion or the prototyping phase. If there's a problem with the assets, we catch it at the creating content phase, not the implementing phase. If there's a game-breaking bug or something, we catch it before it gets into the build, not after it gets into the build. We automate parts of the pipeline. This is where tools programmers get in. This is a very exciting thing that, again, might be a little bit out of scope for GDW, but for those of you who are interested in tools programming, there are different ways you can take the sections of the pipeline and automate them. An example might be you might have a particular format that you might need an asset to be in before you get it into the game. Maybe an easier way to do that would be to, instead of relying on the artist to export it correctly, you make a program and you take the human out of the equation. And the more ways that you can take the human out of the equation, the less inconsistency that you will have. So that's why tools programming is very, very big in the industry. But anyways, the main idea of DevOps is again to avoid crunch, because as long as we are making these small batched, very thoughtful, laid out pieces of our tower rather than just going and making giant blocks at a time, we can take the time that we need and measure things accordingly rather than just trying to get them done. It asks us to find weaknesses in the pipeline and find bottlenecks, which is a great process because it allows you to see where your team might need some extra help. Maybe you have 3 artists, but you have 1 programmer. Your programmer is creating a bottleneck because they don't have any extra help. You might be creating 3 times the amount of assets that the programmer is able to implement in one day. So recognizing bottlenecks like that in your team's process is imperative to improving it. Because again, if you can make anybody's lives easier, you should be focusing on the bottleneck of the pipeline. And lastly, you want to measure, well, you don't have to measure everything, but you want to measure those hours that you put in so that you can take a calculated approach on how you want to improve your team. Maybe somebody is putting in way more hours than somebody else. Is it because, well, that person is more committed, or is it because they have to work 3 times as hard because there's 3 times as much art? What can we do to mitigate this? That's why tools like Clockify are essential. So I want to talk a little bit about quality assurance here because I mentioned it a little bit in terms of testing things. but I just wanted to add a little tidbit because I think it's important. You should really be assuring that everything that you make in the game pipeline is great and wonderful and well packaged before it gets sent off to the next part. Are we following the art direction? Is the code modular and optimized? Are there bugs in the game? Is there a problem with the design? Is the design unclear? These are the kind of questions that you should be asking. Now, depending on the size of your team, for programmers, you can do something like code reviews where everybody looks and comments on like how maybe to change the systems to make them more modular and expandable. For artists, something that you could do is have meetings where everybody takes a look at the art that's going to be put into the implementing content phase and makes sure, does this actually, or even then, even before the implementing content phase, you could do it during the art prototyping phase. You could make sure, does this actually fit with our concepting? Is this cohesive with the vision? And by doing those little tiny reviews and introducing that kind of layer of testing redundancy, you force yourself to reevaluate these things multiple times, which ensures that there is quality in everything that you do. Now, for some final tidbits, you want to explicitly define your tasks and the responsibility that they entail for project management. So, for example, if somebody tells me go make a movement mechanic, does that mean I should be like, am I doing the particles associated with the movement mechanic? Probably not, but maybe I should specify that, that person is only doing the movement. They're only building the architecture. Or maybe that person is supposed to implement everything to do with the movement mechanic. That's something for you and your team to decide. But explicitly defining your work, just like explicitly defining design, is going to make sure that everybody is actually doing the things that they set out to do and not accidentally making work that doesn't belong. Having feature ownership is actually a very, very good way to do things, especially when you're working with multiple programmers. So what is feature ownership? Basically, imagine if you have a couple of different, like, I don't know, an FPS game where you have guns and you have movement and then you have enemies, let's say. And let's say in this case your team also has three programmers. Those three features would belong to three different programmers, let's say. So let's say I own the movement mechanic. Uh, Programmer 2 owns the gun mechanic, Programmer 3 owns the enemy mechanic. By allowing these people to have ownership of the implementations of these different features, we can always know who to ask if there's a problem with one of those features. Plus, we can always rely on them to be the one that have to accurately recreate the vision of the game designer in the game. This doesn't extend, or sorry, this does extend past just gameplay programming. Um, you could look at feature ownership in the similar way for art, as in like something like asset ownership. The person who's modeling enemy A should be responsible for how that enemy ends up. And if there's a problem with that asset, it should be sent back to them rather than being sent to somebody else to fix because they probably have no idea what's going on with that. Anyways, that aside, the biggest thing is continuous integration. That is the builds, as we've mentioned many, many, many times. Build as often as you can. Build every time that it ends the week, or every time you're able to do that. And it's not to say make a number change in build. It's to say if I add a movement mechanic in my game, I want to make a build of that so I can go and test it and I can send it to people for them to test it. If I add guns into the game, I want to make a build so then I can test it. I want to do all these things so I can actually see when I open up the game, what does it look like? Because often in GDW, we don't actually experience that. We don't actually experience what does the final build look like. And now with this continuous integration solution, we don't actually have to worry about that. We can just say, what does the build look like right now, and what do I want it to look like at the end? And you build those little tiny pieces in succession. And the last thing that I want to leave you with is that continuous delivery or continuous integration is not magic. It's about continuous daily improvement at all levels of the organization, the constant discipline of pursuing higher performance. So again, the main ideas of all of this is to be aware and to look at your different processes that are happening on your team and see where you can improve. How can I be a better teammate? How can I code this thing so that it is more designer oriented? How can I do these things better? And yeah, that's the basic idea. I say basic, but you know. So yeah, I just want to also, I'm going to go back to this slide because I just want to hammer home how important this and builds are. Um, if you're going to take away anything, I want you to take away builds and the pipeline. If you follow this process, it's going to make it a lot easier. Just make sure it's measured and that you can hold everybody accountable to what they're doing. So, yeah, that's the session, guys. Thank you. All right, I'm going to stop the recording now.